Hi everyone, my name is May, and in this short video I will be solving question 2 from Benchmarking Clinicians. This presentation was prepared as part of HAP823 taught by Professor Alemi at George Mason University. So this is the question. So it says, the following data report patients with 10 diagnostic related groups and 3 HCC indices cared for by a clinician in his peer group. Use SQL to determine if the clinician is more efficient than his peer group. So first of all, download the data and import it using SQL Server. So when you download the data and open it in Excel, this is how the data looks like. We have 5 columns. We have length of stay. We have doctor, so if it's peer or if it's the clinician. And then we have a column for HCC and a column for DRGs, and we have the ID column. So the first step that we're going to take is to actually calculate the pattern of care for clinicians and for peer groups. So we're going to use the same SQL code for both of these tables. So the first table is for clinicians. So we're going to declare an attribute as a float, and then we're going to set the attribute by counting IDs from our original table that we imported with a where condition that specifies that doctor equals clinician. And then we're going to select the RG, HCC, and we're going to average length of stay. And then we're going to count IDs, and then we're going to actually count IDs again, but dividing it by the attribution that we declared as the probability. And then we're going to put it in a temporary table, and we're going to stay in the where condition where doctor equals clinician. And this is how the table looks like. Moving on, we're going to use the same SQL code, but this time we're going to specify in the where condition where doctor equals peer. So the same exact code, except the where conditions will be different. And of course, you're going to change the column names and put it in a different temporary table. And this is how actually the table looks like. So after we're done so, now we are going to match clinician and peer group on Strata, and we're going to use this code. So we're going to case when HCCA, which is from the clinician temporary table, is null, then HCCB, which is from the peer temporary table, else HCCA and end as HCCA. And then we're going to do that for the rest of the columns. And then we're going to put it in a temporary table called match, and we're going to full join on DRGA equals DRGB and HCCA equals HCCB. And this is how the table looks like. So the next thing that we're going to do is actually calculate the overlap without using synthetic cases as we have done in the previous step. So we're going to use the table match, and we're going to use this code to calculate the percent, and we actually got an 81.48%. Now, in the next steps, we are going to increase the overlap percentage by using synthetic cases. So the first step is we're going to switch probabilities and calculate missing outcomes. So as you can see in this code, we are going to select everything from A, and then we are going to case when length of stay is null, then we're going to average length of stay from our tables, the match table that we created before, but we're going to specify where doctor equals peer. And then we're gonna put it in a temporary table called all, and all of these information are from our match table. And this is how the final result looks like. So the next step is to actually calculate the overlap after we have used the synthetic cases as shown in the previous code. And we can see that using the same code, of course, the one that you used before, and we can see that the overlap is 100%, which means that we have done a successful job in increasing the percent. So after that, we need to specify the length of stay for clinician, for peer, and we want to see if the clinician is more efficient than his peer group. So we're going to use this code to determine these three things, and then we are going to compare. So the code as shown here, we're going to select round sum. So we're going to select probability A, and then we're going to multiply it by case when length of stay from B is no, then 0, else we're going to put length of stay A, and then we're going to end it as the clinician length of stay. So this is the clinician length of stay. So let's see how we're going to do the peer length of stay, which is we're going to take probability B, and then we're going to multiply it by length of stay B, and then we're going to see who is more efficient by uh, taking probability A and multiplying it by case when length of stay B is null than 0, else length of stay A, and then we're going to end it as a float. And then we're going to multiply it by 100, and then all of this is divided by the same thing, but in this case is probability B, multiplying it by probability B. So as you can see, these two lines of code is actually from the previous lines that we just did, except we're dividing it together and to get the percent of if the clinician is more efficient or not. And then where, of course, the table is all, the one that has all these columns. And this is the result. So to conclude, the length of stay for clinician is 2.96. And the length of stay for his peer group is 3.05. So we can conclude that the clinician is more efficient than his peer group by 2.78%. This concludes my presentation. I hope that you found this video helpful, and thank you for watching.